Welcome back to Incremental, the continuous improvement podcast. This is our practice edition where we go over improvements throughout the week and talk about the lean principles behind them. My name is Uriel Eisen.
And I am Devin Bedoni.
And you have a quote?
Testing over talking. When you hear statements like, I believe or I think, stop talking and take a step. From Toyota Kata.
Yes.
I've had that book open in Amazon to order for a week and
nice.
haven't done it for some reason.
Yeah, I'm really liking it. Yeah, I think this is very solid. There's a lot of, I think sometimes when there's disagreements about like a next step on a project or something, everyone has it in their head what will work and what won't work. And sort of like, well,
yeah.
None of that matters. It's kind of like, what should we try next? Yeah, and I have to remind myself for sure of this frequently. I think especially when working with people who maybe have less experience building stuff, of just like the fact that they are doing it is awesome instead of like, oh, well, have you thought of this or have you thought of that? Or it's like,
yeah.
All right, you're on your own journey here, like, and it's, like Sam is not from a building background, and, you know, I grew up building things, and so, like, some of the improvements are not built the way I would build them, but they still achieve two things. One, him starting to just view the world as, not just the world, but, like, the systems as changeable and encourage, and that being encouraged, and that the implementation doesn't super matter.
Yeah. Because
it's actually just an experiment to see if it is an improvement, kind of.
Yeah.
And then also, I mean, that's how you get better, you know.
It is.
And like worrying that it's not up to a certain mark does not do any of those things, I think.
Right.
You know, as long as it's not unsafe.
Yeah. But I have like kind of an interesting take on, or a different take on this. That's a challenge that I face.
Yeah.
Often, not so often, but occasionally with jobs that we get, you know, I'll quote a job at a certain amount, and a certain portion of that is, you know, dedicated towards like figuring out how we're going to do it and setting it up.
Yeah. And
there's not a lot of like margin for extra time or room for error in that process. And so obviously with experience, I'm getting better at this, but there's still, you know, relatively often this point where I have to be like, I just have to go on belief that this is going to work, and sort of be like, I don't have the time to test or the resources to test a couple different options. I have to like do my best and then be like, I'm going to take a leap on this one and hope that it works out. Because if it doesn't, we're sort of hosed on this job.
Yeah, that's tough.
It's an interesting challenge. It's getting less and less stressful as time goes on, but it used to just be like, hilariously, I would sometimes procrastinate for days.
Right.
Because I was like not prepared to actually take that leap. I could have done a lot of testing and all that procrastination, but
sure,
you know, that's not how our brains work.
And do you attribute that to just more experience
now?
Yeah.
Yeah.
Okay.
Yeah. I think more experience. I have like a couple like kind of tried and true recipes that work for the bulk of things. And then occasionally there's still like we're going to take a crack at this one and see where it goes.
I wonder over the past months, I feel like a theme on your end has been thinking about how to alleviate the bottleneck of programming. I wonder if it would be I suspect it would be a good use of time to try to codify the tricks, like different types of parts, and how you like best practices for fixturing and that kind of thing, like op 1, op 2 idea, you know, just I'm trying to think what it would look like, but I bet it would be very informative for you, and then also super helpful for whoever you start to plug in there. And also it might be that it's very clarifying to say like, oh, this type of job is where we should focus on like our handoff, because it's very easy. We have like 50% of our parts fit into this paradigm.
Yeah.
And it's very plug and play. Like, anyway.
Yeah, no, that makes a lot of sense.
Because then also the experimentation of we tried something and it failed isn't just straight like organizational not making money on this job, right? It can start to like plug into a knowledge base. I don't know.
Yeah. On that note, last week I talked about not having a good sense of kind of like what my overall mix of part sizes were. And Rob Lockwood reached out and said, you can have your post output that, and then it's easy to scrape the data.
Like stock size or something?
Yeah. So I then reached out to Phil, who works at DSI and is working on our post edits.
Oh, gotcha.
And I was like, is this easy? And he was like, oh yeah, it's actually really easy. So going forward now, we'll have stock sizes for every job in the post.
Wow.
Which is like, I think will be helpful from a, being able to look back at historical data standpoint, but actually is more helpful in the immediate in that he was able to output it in a format that gives its orientation in X, Y, and Z, which is something I have to punch in every setup sheet anyway, so that an operator can't load the part incorrectly. And then he was also able to add a line where it gives that part's reference to the active WCS in work coordinate system in CAM. So you can, with a little bit of thinking, extrapolate where the part is actually set up, like where the origin is actually set up on the part. Not exactly sure how we're going to use that data right now, except as like a sanity check during a setup. There's probably a lot of ways we could use it, and the more we get into this post stuff, I'm like, I think there's a lot of potential to drive like an amazing amount of information through the post, just like figuring out how to ask for what I want.
How to know what to ask for what I want.
And then how to format it in a way that's like easily usable.
Interesting. Now, it does make me think that the setup sheets here are exactly that, where they have access to all that data. Yeah. But they're designed to create a document that is optimized for readability more than G-code.
Yes.
But I've not seen a lot of people using them.
Yeah, and then the one thing I started messing with it a little bit, but maybe I'm just doing something wrong. Please reach out if this is the case. But at least in HSM Works, it seems to put out an HTML file, and then it opens in a browser, which is not what I want. I guess it could be usable, but it's kind of a weird...
And it opens like a PDF, basically.
No, it opens like a browser window with this information on it.
I wonder if there's like a preference somewhere. Yeah. Have you Googled it?
A little bit. There's very little information on HSM Works specific stuff. Gotcha. There's a decent amount on Fusion, and I'm not sure. It might be the same in Fusion.
Right. I haven't messed with it.
Yeah.
Interesting.
We'll probably have to transition at some point. Not too distant future. That's a topic for another day, though.
Cool. Well, jumping into some improvements. So let's see. This is a small one, but I feel like speaks to this idea of like take your focus off of your core processes and instead focus on all the other ways you spend time throughout your day.
Right.
Scheduling. Yeah, I know you did this. Scheduling package pickups. It's like two things. One, we were sort of talking about like flowing value to the customer.
Yeah.
And I feel like we sort of have this false idea in our heads that like once the part is kind of made and in a package, like our job has been done. And that's not really what the customer is paying you for. Like they're actually paying to have it.
Yeah.
Right. And so like there's a little bit of like, okay, well we did it and now we just need to drop it off at some point. And like that somehow mentally gets lumped into like when I'm going home, I just take it on the way, to the post office. But it adds time. It definitely has been missed before where something like I'm behind schedule or something and don't have time. And yeah, it's just like another thing that we have to sort of worry about. So with USPS, which is the way we ship most things, Sam has been looking into it, figured out, I guess you can select, like ask them to come pick stuff up. But we haven't figured out yet, just like we want you to come by on your route every day and just have a look.
UPS makes it very simple to do that for whatever reason.
Yeah. Unfortunately, UPS is quite a bit more expensive for us with the packages we're shipping.
Interesting. So not to cut you off.
Yeah.
We set up that pickup via UPS directly.
Okay.
We ship out of Pirate Ship.
Yeah.
Which
has better rates.
Has much better rates with UPS. Yeah. They're comparable or often cheaper than USPS.
So you're probably shipping bigger stuff. We're ship all
kinds of sizes.
Most of our stuff is under a pound and is in a padded envelope. And for that, we just use like first class mail, which is like $3.50.
Yeah, I'm gonna look it up right now while we're talking.
Oh, cool. Yeah, I mean, definitely open to using a different service.
I'm just thinking
if they
make
it easier to come pick up.
Yeah, it's a very real possibility.
Yeah, and then the other benefit there, if they do have comparable rates, would just be that I know over time they'll sometimes improve your rates, which I think USPS is very unlikely to do. Anyway, so that was a little improvement. So Sam figured out a way to have them come. But yeah, again, we're trying to figure out now a way to get them to come daily without having to request it.
Yeah.
While you're looking that up, I can keep rolling here. Last week we spoke about a keyboard drawer.
Oh yeah.
So those arrived and we installed one of them. It is big. It gets the keyboard and mouse off the table, gets the wires off the table. Separately,
it's big as in it's awesome.
It's big as in awesome.
Yeah.
It's also sizable, but yeah. So that's great, and it just sort of makes the bench a lot neater, but also it gives us this like really great really important real estate in the shop are these assembly areas, and having a big keyboard and mouse sitting on them doesn't make a lot of sense. Also, the comfortable working height and the comfortable typing height are not really the same. So ergonomically, it's also kind of a nice, fix. So that was good. And yeah, I guess the problem we saw there that made us do it was that the space on our bench, so this, like anyone out there who has an issue with bench space or assembly space or something, kind of asking yourself, like, what are the things that absolutely need to be here for the task that we're running out of space for? And I don't know, it's funny, but we found a bunch of stuff on that table. We're running into space issues, and then it's like, well, that doesn't need to be here, and this doesn't need to be here, and that doesn't get used at this station.
Yeah.
And it's just like where we decided it should be.
Yeah.
Or maybe should is an overstatement. It's where it ended up, and then it's hard to like rethink it.
Yeah, you're right. So USPS still considerably cheaper, about 50% less.
Yeah. So, yeah, I had looked a little while ago, but always good to.
The question would be whether that savings is worth the hassle.
Yeah. I just, I know USPS comes and picks up from big companies.
Right.
So, like.
They do come by every day, right? Like,
yeah.
It might just be that you don't have a shipping address, like, quite the same way.
Yes, I think we need to, because I'm thinking like if it was just a mailbox,
yeah,
and we stuck all this stuff in a mailbox,
right,
done. So
could you have you tried just like actually going to the post office and talking to them?
I have not tried that. Seems like a great way to do it.
I think they're pretty old school that way.
That's true. They might be a lot easier.
It might be you go talk to the postman and
that's a good call.
See what they say.
Yeah.
Nice. Well, my big improvement of the week, kind of the only major thing, but it was a big win. Also had to do with the post processor, and finally carved out some time to do some more testing. If people recall, I had that probe crash last time. I tried it, so I had to do some edits, or not I asked for some edits. Mm-hmm. And then yesterday had a part that would benefit from it, and I was like, okay, we're gonna take a little extra time, troubleshoot it if we need to, but we're gonna launch this into production process. And so we used our new post with the rotary fixture offsets, G54.2. It worked flawlessly.
Wow.
Without any issues, and 0 hand edits.
That is amazing.
For anything. So there was the G54.2 stuff, which was great. Probed straight out of cam, wrote to the right offset. Everything just ran properly. But then there was all the other hand edits that I often do for like block skips on probing so that you can jump through a program. Tool breakage detection is now automatic.
Wow. Is that a toggle or it just puts it in?
It's based on how you have the tool set up.
Gotcha. So you can set it up in the tool.
Yeah.
Gotcha.
So maybe it would be good
sense.
To add a toggle at some point if you want to just turn it off. But
right.
I think I'm going to leave it on. The one thing I need to do is figure out, I need to adjust the tool breakage detection subprogram so that it puts the rotary back to 0. Because on one of my machines, the rotary's big enough that you could crash the spindle into the trunnion if it's
that would be
at the wrong angle. Yeah. So that's a little detail I need to tackle.
This feels like a big detail.
It's a big detail, yeah.
Because it really rockets over there to do its thing.
At full speed, yeah.
Yeah.
Absolutely.
I wonder... I think with each new toolpath, because that would be a call at the end of a toolpath. With each new toolpath, it will go back to an A position with the rotary, right? You wouldn't be like pushing it out of position and then the main program doesn't.
It's not at the end of each toolpath. It's before a tool change.
And with the new tool change, you get X, Y, Z, A.
Yeah.
Gotcha.
Yeah.
Cool.
The trouble right now is that it doesn't do the new X, Y, Z, A until the G100 tool change line. And so if you finish at A90 or A270 or whatever,
go check and then move.
Yeah, exactly.
Yeah, so with that, because you could rotate it while it's getting over the tool setter in that, right? It retracts. Mm-hmm. And then you could do a simultaneous X, Y, A move.
I believe so.
I'm trying to think how that would crash.
I might leave it not simultaneous. Right. Just sacrifice probably a quarter of a second, maybe a second.
Yeah.
So yeah, anyway, that was our big...
Oh, you could not have it do the brake. That would save a bit of time.
What's that?
You could have it not turn on the brake, the A-axis brake.
Not turn it back on?
Yeah, because it would turn back on after its move. I don't know. Anyway. Or just make it happen, and it'll be way better than a crash. Yeah.
So anyway, that's a huge load off. I hadn't quite realized how stressed I was having this unfinished project.
Yeah, that's huge. And like those hand edits are risk. Like they just are.
They're a lot of risk.
Like you're literally typing in, for anyone who's unfamiliar, these machines rocket around very fast. They're quite powerful. And they have no idea what they're doing. So if you tell it to do something that will destroy something, it will destroy it. Yeah. No questions asked.
And turns out we're not that good at typing exactly what we want to.
Yeah. So like if you put if you just fat finger something and leave out a decimal, you can crash it. Yeah. I mean, there's just so many ways to crash it.
Yeah. My friend worked at a machine shop when he was like 18, 19. He's not a machinist anymore. Wasn't really then. He was just working as an operator, but he worked on a CNC lathe, and his boss would type out the programs and then he would hand enter them.
Okay.
And he had one spectacular crash where it was like, instead of a 10 thou per rev feed rate, it was 100 thou per rev feed rate. And he threw a part through the lathe window, like into the wall. It was
yikes.
Real spicy.
Yeah.
Yeah. When I first posted it out and like just sent it to the machine without any hand edits, I was like, something's gotta go wrong.
Did you do like a short program so you could watch it, or you just full send and watch the whole thing?
I watched the whole thing.
Yeah.
I had pretty good so I didn't edit the code. I did read through the code.
Yeah.
Not like every line, but go to all the tool changes and everything. And so once it started like cutting in the correct position, I had decent confidence that like,
if it did it once, it'll do it again, kind of thing.
That at least the like basic tool paths were going to work properly.
Yeah.
And like once it did a first like rotation move and like indexed to the proper point and everything kind of like, transformed around this theoretical point in space properly, I was like, I had pretty good confidence in that. It was, most of my concerns were around, tool changes, like codes not canceling properly, something weird happening at a transition, and but it all just worked.
That's awesome.
Yeah.
It's reminding me, I don't know if you listened to the latest Business of Machining.
I believe so, yes.
Anyway, Grimsmo got the new chipset on his Speedio.
For the accuracy, or the
that was kind of fascinating to me.
Yeah.
Because it's odd that they wouldn't include that if it is just a more accurate machine. Like, I understand that at that point, the fact that it's a machine without thermal controls at all, like that level of precision is kind of, it's not silly exactly, but like what he's doing, which is surfacing without like absolute positional tolerances. Right. It's just sort of
those machines
tool path to tool path.
Thermal control, just not.
They have thermal pretend control.
Yeah.
They have software compensation, right?
Yeah.
They're not keeping elements at relatively stable temperatures.
Exactly. Yeah. Apparently, as with many things, their methodology is different than a lot of other companies.
Okay.
But again, going back to kind of their like production heritage and focus, as I understand it, their thermal controls are actually like amazing if you use them in the way they're intended to be.
Okay.
Which is like, you run your production part, you test, you feed back into it until it's like absolutely perfect, and then it does the same thing over and over and over.
Gotcha.
And it like can compensate perfectly because it's based on real data.
Interesting.
But for those of us running 20 of one thing and 1 of another and then 50 of another, it's kind of pretty useless.
So because I'm only running like
10,000,
5, well, no, I'm just thinking I don't run that many parts, and they're all in a similar envelope. I bet they're all very similar.
I bet they're all very similar, yeah.
Characteristics. Anyway, very
you
interesting.
Don't really need it, probably.
I don't need it at all.
Yeah,
for sure.
Sorry, I totally cut you off.
No. It's just interesting to me that exists for these machines, but doesn't ship with it. I would love the extra decimal for like comping things in, because sometimes it's like 1/10 is whatever. I don't know. Like, it would be nice to have that middle ground, but I don't know if it's a few $1,000s nice. Anyway, kind of interesting.
Well, that's probably your answer right there, why they don't ship it. Is probably,
I guess. Do you think it actually costs them? I guess maybe that chip is expensive.
I don't know.
I have no idea.
Maybe the same reason they don't ship with a jog handle.
Right.
It's like some people don't want to pay for it, so they don't include it unless you ask for it.
Yeah.
I don't know.
True.
Yeah.
They probably have their reasons. This is definitely off topic, but I've been following these car companies rolling out more subscription stuff, like subscription to more horsepower. Like,
is that a thing?
Oh yeah.
Oh,
it's
wow.
coming. It's coming.
Interesting.
Yeah. Starts for like.
For electric cars or all cars?
All cars.
Wild.
Yeah, they're adding like monthly subscription packages.
So you go to the races, you can just.
Recurring revenue is the name of the game. Everyone wants it.
Interesting.
Kind of bizarre.
Do you think it's going to last? Like, do you think Like, I wonder how long that paradigm will exist before either people refuse to interact or someone figures out a more effective way.
Right. I think this is a very awkward like tween phase because I think cash flow wise, it is very helpful to be able to rent things and like just subscribe to them. Right. Like instead of having to pay $100,000 for a new CNC, you can pay whatever a month and you're getting the value out of it and everyone's happy. Or like some of these software packages, I understand why they're going to a subscription model. And actually it's sort of similar to a machine. It's like we use that software every day. We create a lot of value with that software. It's fine, right? I don't know if it's everyone prefers it, but it is fine. But with this thing of like, I'm going to pay you whatever, $60,000 for a car, and then you want me to like pay you $10 a month to have heated seats. There's something psychologically about that that doesn't feel quite right, but we'll find out. I don't know.
Yeah. Interesting.
Anyway, back to things people actually come here to listen to. Avi, our good friend Avi, sent, I don't know if you read
I didn't actually read it yet.
Really cool. So we've both been 3D printing a lot of automation bits, and I've seen a lot of cracking in the plastic parts over time, and kind of interesting failures. And so this is a paper on exactly what the mechanism is for it's called environmental stress cracking. So apparently it was saying about I forget, it was like 40 to 60% of plastic parts out there, this is their failure mode, is environmental stress cracking. We've all seen it. It's like little radiated cracks around a screw on like a piece of acrylic, or like crazing on polycarbonate, all this stuff. So the mechanism, not to get too in the weeds here, but basically little stress risers, like they typically start at a little flaw in the surface, so like a little nick or something. And if you think about the surface of a 3D printed part, it is all nicks. Where each layer gets deposited, there's a sharp internal corner, so that's a big stress riser. But basically,
also the actual like extruded surface is not perfectly smooth by any stretch.
Oh, that's true. Yeah, I wonder how micro is. I mean, probably pretty small considering this is like a chemical. Yeah. But basically, what happens is each material has like a yield strength, at which point it will break or fail or crack or something. Yeah. But the second you add an environmental, like a chemical that reacts to the plastic, what's happening is that with plastics that have, I forget the exact terminology, but basically if you think about the molecular chains and they're disorganized, there is actually the plastic could become more dense if you orient it. And because of that, I forget what they call it. It's like total filled space, or it's not that, but it's something like that. If you have a chemical that is soluble in the plastic, it will plasticize at the highest stress locations because of like preferential absorption into the plastic. And then the polymer chains orient in the direction of the stresses at that one area, which leads little voids because now they are oriented. And then those little voids start to propagate cracks. And if it absorbs a lot of the material, then your stresses from swelling at the surface increase the total stress time. And so this is all like a stress and time continuum.
So what's absorbing the material? The
polymer is absorbing some chemical in the environment.
Gotcha.
Sometimes.
And so it's actually becoming part of the plastic chain molecular structure.
I don't think it's becoming part of the molecular chain, but it is softening the plastic, and then those molecular chains reorient to the direction of stress.
Okay.
And then it's leaving space, like literally spaces, like voids, which start to propagate cracks. And so what they were basically saying, and there's like test procedures that have been developed. This was found in the 1940s with a company that was putting polyethylene as insulators on wires, and they were finding cracking in certain environments, which I always thought of polyethylene as very resistant to A, chemicals, but B, just sort of like that failure mode of cracking. But there are some chemicals that do absorb into polyethylene, and then same process. It orients the polymer chains at the points of stress. That creates little micro voids, which basically turn into crazing and then cracking.
Very interesting.
And it's basically, if you have stress on the plastic plus an environmental chemical that has this effect on that particular polymer, it's sort of this continuum of how like stress and time and reps.
Yeah.
For this process.
Right,
and so
because you're just getting into a classic like stress strain like cycle, and
and then your polymer is like changing characteristics and whatever, but it is about stress and time and reps. And so if you think about our application of the automation, it's like the perfect storm, but
it's also very easy to predict potentially.
Probably that. I think we'll probably do time-based. But the other thing that I was curious about,
like you could add a counter very easily that would just tell you exactly how many times
change your fingers.
It's opened and closed, and then throws an alarm or something.
That's true. A few other things that it mentioned is that absorption has a big effect, tends to have a big effect on this phenomenon. And so I was sort of wondering if we could just take, like, as a useful way of deciding which filament to use, because I'm not going to stop 3D printing these parts because it's so convenient.
Yeah.
I was sort of wondering if I just soak a chunk of the polymer in our coolant and then weigh it after, if that would give me a good sense of which material is going to perform the best. The other option is to basically print test samples of the different, all the same shape, give them a certain load, and then expose them for a consistent amount of time to our coolant, which in our case is our environmental contaminant, and then see what happens. And there's a procedure that they list in this paper,
and so
on how to do it. I'm just not sure I want to spend the time to set it up.
What about coating?
That was the other thing. It seems like if you just dipped it in something that was super resistant, like some really watery,
like a thin epoxy or something.
Yeah. So that might be the answer.
Obviously
there.
It won't be perfect, and you'll still get infiltration at some point. It'll probably wear off at the very tip,
right,
where it's contacting the parts. But if that's not where it's failing, maybe that's not the issue, and you might get 4 times the life out of it.
Totally. And I think we're sort of at this funny thing where like the 3D printed parts are so cheap and so effortless,
right,
that it's sort of how much time do we want to spend solving the problem? But it is kind of, I don't know, part of what I love about this is just that someone took the time to document so thoroughly. I mean, it makes sense considering how frequently we use plastics.
Oh, yeah. I mean, I actually haven't watched it, but there's some video documentary about how, like, plastics are the entire reason we live the existence that we do.
Interesting.
Like, you could not have, to the extent that we do, electricity in houses without plastics because of the insulators that you're talking about.
Interesting.
And all of this technology, like the computers that we're recording on, the mics.
Right.
This is all, like, we think about it as being like, oh, electronics and metal and wires, but no, it's like plastic. Without plastic, this stuff is huge and it burns your house down.
Right. There are still some old houses that have the old wiring where it was like strung from ceramic insulator to ceramic insulator.
Yeah,
it's pretty terrifying.
It's absolutely terrifying. And, not to mention all of our whatever clothes and containers and all that, but like the electricity thing is real.
So it's so cool to me that someone like documented the step-by-step process. I'm so curious about how they figured all that out. Like, how do you see that the polymer chains are orienting? Is that what they're deducing, or can they physically see the polymer chains?
I don't know.
It's kind of curious. It's also always amusing to me how much material science is like, you can totally intuit it based on like very basic mechanics. It's kind of hilarious. Like, I have a friend who was working on making, I forget what polymer, but it's a plant-based resin that's in use quite a bit. It doesn't hold carbonation well, so it's not used in like beverages, carbonated beverages. And so his and he was describing, so it has these carbon chains that each part of the chain has, it's like these carbon molecules where they have two contacts. And so each hexagon of carbon can actually rotate about those 2 points of contact. And so he was trying to figure out how to add a third so they couldn't pivot, because every time they pivot, CO2 molecules can push by them. And they just sort of pivot out of the way, which is just wild. Hilarious. Similarly, like plastic films are often oriented. So there can be like non-oriented films, and then there's like biop, which is like biaxially oriented polymer, and whatever single oriented polymer. So it's like some water bottle labels will tear really easily in one direction and not in the other. That's because the polymer chains are running in the direction. It's like wood grain almost. And the way they do it is also hilariously simple, which is after you make the plastic film, if you stretch it one direction, if you imagine putting a bunch of like pasta on the floor and then sort of stretching all the pasta, on average, you're pulling more of those noodles into that direction. And so like it gets stronger in that. Anyway,
plastics are wild. I didn't realize for a long time that like heat shrink tubing for electronics stuff. It's actually the finished size is the tubing.
And then they just stretch it out.
And then they just stretch it like crazy. And then you heat it up, it relaxes back to its original state.
I wonder why it wants to relax back to its original state.
I don't know. I guess you've probably put a lot of stress into the system, and I don't know. I don't know enough about plastics, but I remember reading that and being like, whoa.
It's strangely basic. Interesting. Anyway, so thank you, Avi, for sending that over. Super interesting to have a real answer as to exactly what's happening. They also listed plastics and how susceptible they are to different chemicals. One of the chemicals that is listed for polyethylene families in general, I guess are, and I might be wrong about this, from my 20 minutes of reading here, a big contaminant are surfactants, which coolant is like bonding oil into water, which
straight up surfactants.
So I'm guessing there's something in there that's really devastating. Have you been having the same issues because you use a different coolant?
I have not, but we also don't run it nearly as much, so I'm curious if it's just a matter of time. Last time I looked, I didn't really see much.
So according to this paper, it is straight like stress, time, and reps. And that's exposure time to the chemical and also reps. So the other takeaway for me is definitely if we reduce the PSI stress in the gripper fingers, that should extend the life quite a bit. So I think we'll either do more solid layers or potentially I don't know. But also the coating thing is like there must be some basic paint that we could just dip it and it would take care of quite a bit of it.
You got to think.
Because I'm also thinking that swelling will maintain a baseline stress that's pretty high, where the outside of the part has swollen and the inside hasn't, and it's like So like even if you could eliminate it from Anyway,
interesting.
Last improvement, which was kind of embarrassing. I've had a very slow leak on my bike tire for the past like month and a half.
Which is your primary mode of transport?
Yeah, I ride it every day. And it's almost made me miss the boat a couple times because I like come to my bike.
Boat being ferry, because Uriel takes a ferry to work and back.
Yes, all these little details. Anyway, slow leak, and so I would just pump it up every few days, basically. And every time I experienced the problem, I was not in a position to fix the problem, which I think is a classification of problem that needs a name.
It's also very typical to cyclists because you always experience it while you're in motion.
Or like
you can't take your hands off.
I need to get on this bike. It is going to take me 40 seconds to pump the tire back up, or it will take me like 10 minutes to fix the problem, and I'm going to be late if I take that 10 minutes now, and then you get where you're going and it's not
time to make dinner.
Yeah, right. And so I finally fixed it, and it's just like I bring this up for two reasons. One, this is has a real effect on production, whether or not people are there, right? And it is a very simple thing. And like, not only does it have an effect on production, it also has an effect on sort of like, they talk about like stability of process, and that it's very difficult to implement any of this stuff if you don't have stable processes. And stability means reliable, like when you need them, you want them, right? Like if I tell you reduce your inventory, and then simultaneously I tell you that the machine that's going to replace that inventory, sometimes it's going to work, sometimes it's not going to work. Like you just suddenly need a lot more buffer.
Yeah.
Anyway, but the other piece is I just feel like there's a lot of things that are in that category that I am dealing with every day that I just am not seeing in a funny way of like I've been like cleaning a lot of surfaces off. They are dusty, like the top of the CNC I've been cleaning, very dusty. Kind of like, where's that dust coming from? You know, like, could I filter it before it lands on my things? Maybe not. I don't know. Right? Like we do these things, like sweeping the floors, like all this stuff. Like, what can we just fix? Like, take a little bit more time and just like fix it. Yeah. Anyway, that's that.
Get away, dust.
Exactly. No one wants you. Thanks all for listening.
Yes, indeed.
You can find me at austere_manufacturing on Instagram and austeremfg.com.
You can find me at lichen_mfg on Instagram and lichenprecision.com on the World Wide Web, as they say.
And incremental CI on Instagram. Appreciate the tags, trying to repost, trying to do a better job of being on top of that. All of you who have tagged in improvements, it's always fun to see and show everyone so we can all improve together. Till next week.
Catch you later.